DNS is the phone book of the Internet. You type contoso.com, DNS converts that into an IP address your browser can actually connect to. Here is the lookup chain. Your browser asks a DNS resolver. The resolver asks a root server for the .com zone. The .com server points to your authoritative name server. Your name server returns the final IP. This happens in milliseconds, before your page even starts loading. TTL controls how long that answer is cached. Short TTL, changes propagate fast, more queries. Long TTL, fewer queries, slower propagation when you change IPs. In cloud architecture, DNS is not just name resolution. It is how you route users to the right region, the right endpoint, and the right failover target. Understanding DNS is understanding global routing. Azure DNS lets you host your domain's DNS records directly inside Azure. Instead of logging into GoDaddy or Cloudflare to manage records, you do it all in the Azure portal. Here is how you set it up. Create a DNS zone for your domain, say contoso.com. Azure gives you 4 name server addresses. Go to your domain registrar and update the NS records to those 4 addresses. Done. Azure now answers all DNS queries for your domain. The big advantage is integration. Your DNS records live alongside your VMs, app services, and load balancers. Same RBAC. Same portal. Same automation pipeline. And Azure DNS runs on the same Anycast network as the rest of Azure, with a 100% uptime SLA. Let me cover the DNS record types you will use most in Azure. A records map a hostname to an IP address. www.contoso.com points to your load balancer's public IP. Name records map a hostname to another hostname. Use this to point your custom domain to an app service or CDN endpoint. Note, you cannot use a name at the zone apex, contoso.com itself. This is where Azure alias records come in. An alias record points directly to an Azure resource, a load balancer, traffic manager profile, or CDN endpoint. When the resource's IP changes, the alias record updates automatically. No stale IPs. No manual updates. Use alias records wherever you can in Azure, they are smarter than standard A or name records. Public DNS zones handle internet-facing name resolution. Private DNS zones handle name resolution inside your Azure VNets. Here is the problem they solve. Your app server needs to call your database. You do not want to hardcode an IP. IPs change when you redeploy. You want to call it by name, db.internal.contoso.com. Create a private DNS zone. Link it to your VNet. Enable auto-registration. VMs in that VNet automatically register their names. Now your app server calls db.internal.contoso.com and gets the right private IP every time. Nobody outside your VNet can resolve that name. It only exists internally. This is the clean way to handle service-to-service communication inside Azure. Azure Traffic Manager is not a load balancer in the traditional sense. It does not sit in the data path. It works at the DNS level. Here is how it works. User types contoso.com. DNS resolves to Traffic Manager's domain. Traffic Manager evaluates its routing policy and health checks. It returns the IP of the best endpoint for that user. The user's browser connects directly to that endpoint. Traffic Manager is not involved in the actual data transfer at all. This makes it incredibly lightweight and globally scalable. No packet inspection. No SSL termination. Just DNS routing. You define endpoints, Azure regions, external IPs, or even nested Traffic Manager profiles. Traffic Manager picks the right one based on your routing method. Traffic Manager has 5 routing methods. Choosing the right one matters. Performance routing sends each user to the endpoint with the lowest latency. Azure measures latency from the user's DNS resolver to each endpoint. User in Mumbai gets routed to Southeast Asia. User in London gets routed to West Europe. This is your default choice for global applications. Priority routing is simple failover. Primary endpoint gets everything. If it fails health checks, secondary takes over. Use this for disaster recovery setups. Weighted routing splits traffic by percentage. Deploy a new version to one endpoint, send it 10% of traffic. Watch for errors. Gradually increase the weight. Clean canary deployment with zero infrastructure changes. Geographic routing enforces data residency. European users only reach European endpoints. Required for GDPR and similar compliance requirements. Traffic Manager continuously monitors every endpoint you define. Every 30 seconds by default, it sends a probe request to each one. Endpoint returns a healthy response, it stays in rotation. Endpoint fails, Traffic Manager stops returning it in DNS responses. Here is something most people miss about failover timing. Traffic Manager detects the failure in 30 seconds. But users who already have the old DNS response cached will still try the failed endpoint until their TTL expires. This is why TTL configuration matters. Default TTL is 300 seconds, 5 minutes. For critical production workloads, lower it to 60 seconds. Yes, you get more DNS queries. But your failover happens in under 2 minutes instead of 5. Set your probe path to a real health endpoint, one that checks your app dependencies. Not just a static HTML page that always returns 200. Single Traffic Manager profiles handle one routing dimension. Nested profiles give you 2 dimensions at once. Here is a real example. Top-level profile uses geographic routing. European users get directed to the Europe profile. Asian users get directed to the Asia profile. American users get directed to the Americas profile. Each regional profile uses performance routing. Europe profile has endpoints in West Europe and North Europe. It sends each user to whichever of those two has lower latency from their location. Result: users get geographically compliant routing and low latency within their region. One profile alone could not do this. This is how large enterprise applications handle global traffic. When they have both compliance requirements and performance requirements at the same time. These two services get confused all the time. Let me make it clear. Traffic Manager is DNS only. It does not touch your actual traffic. It works with any protocol: HTTP, TCP, UDP, anything. It cannot cache content. It cannot terminate SSL. It cannot inspect URLs. Use it for global failover, multi-region routing, and non-HTTP workloads. Azure Front Door is a global Layer 7 service. It sits in the actual data path. It terminates SSL. It caches static content at edge locations worldwide. It has a built-in WAF. It routes based on URL paths. Use it for HTTP and HTTPS web applications that need CDN performance and security. If you are building a web app, Azure Front Door. If you need global routing for any protocol, or want pure DNS level failover, Traffic Manager. Many architectures actually use both. Let me show you how everything connects in a real multi-region architecture. Your domain Contoso.com is hosted in Azure DNS. An alias record points it to your Traffic Manager profile. Traffic Manager uses performance routing. Users go to the nearest healthy region. In each region, an application gateway handles SSL termination, WAF protection, and path-based routing. Behind each application gateway, your app services or VMs. If West Europe goes down, Traffic Manager detects the failed health probe. Within 60 seconds, all users are routed to North Europe. Application Gateway in North Europe is already running. Zero configuration change needed. This is the standard Azure multi-region architecture. Azure DNS for hosting. Traffic Manager for global routing. Application Gateway for regional load balancing. Each layer has a clear job. Together they give you global availability. That is Azure DNS and Traffic Manager. Next up, Azure VNet Peering and VPN Gateway, connecting networks together. See you there.